Welcome back to Calculus AB, everybody. Today's topic 4.7, using L'Hopital's rule for determining the limits of indeterminate functions. So we return to where our study of calculus all started, which is pretty much limits. So recall that we analyzed problems like limit as x approaches 2 of x minus 2 over x squared minus 4, and the limit as x approaches infinity of 1 minus 4x minus x 5x squared over 3x squared minus x minus 4. So do you recall how to solve these? The notion of plugging in the targeted value of c for x, also known as our green light method, right? You just go ahead and plug it in, poses some big problems in two limits above, and for many more you will see, right? So one of the things, again, we're going to be looking at here is going to be our limits if we do plug in c directly for x. So let's do that. We're going to end up with 2 minus 2 over 4 minus 4, which in this case happens to be just 0 over 0, right? And be careful to put an equals there. And then the next one, if we do, right, if we do approach infinity here, that means that this is going to get larger and larger unboundedly. So this is going to go towards infinity over infinity, all right? So again, these are called the indeterminate forms. There are a variety of indeterminate forms, but the most commonly uh, seen ones are here. So it's 0, 0, infinity over infinity over positive infinity, or infinity over negative infinity, or just negative infinity over negative infinity. You might also see the different forms of the indeterminate forms. For example, 0 times infinity, 0 times negative infinity, infinity minus infinity, 1 raised to the infinity, 0 raised to the 0, and plus or minus infinity raised to the 0, right? You can't just say it's 1, because again, infinity is not a number. So the study of indeterminate forms and L'Hopital's rule is the new AP Calculus exam for pretty much 2017, right? So it's already been 4 years. In AP Calculus AB, we'll focus primarily on the forms involving 0 over 0, or either positive or negative infinity over a positive or negative infinity. The other indeterminate forms will be discussed in length in section 7.7 during the AP Calculus BC next year. So make sure you guys prepare for that. So notice how the two limits we were introduced to at the top of the page are rather easy to solve by factoring and canceling. So consider the following two limits. So limits as x approaches 0 of cosine of x minus 1 divided by x squared minus x, and the limit as x approaches infinity of e to the x plus x over x cubed. So they cannot be solved using factoring or any other algebraic technique for that matter. Yet their limits do exist. And you guys can see clearly on the graph here, right? As we approach 0 for cosine of x minus 1 over x squared minus x, we do have a defined value here. Even though if we do plug in 0, we do run into problems, right? We get 0 over 0 pretty much. And then the same thing occurs here when we're approaching positive infinity. If you notice, it becomes kind of like starts to flatten out, so it actually gets close to an asymptote in this case, all right? So L'Hopital's rule. So if we have one of the two following cases, the limit as x approaches c over f of x over g of x, where both the limit as x approaches c of f of x is equal to 0, and the limit as x approaches c of g of x is also equal to 0, or where both the limit as x approaches c of f of x goes to positive or negative infinity, and the limit as x approaches c of g of x goes to positive or negative infinity. So for any real number c, or for c having the value of infinity or negative infinity, then the limit as x approaches c of f of x over g of x is equal to the limit as x approaches c of f prime of x over g prime of x. So this is a very important statement, right? This is going to save us a lot of work if we're trying to find limits, especially when we get those indeterminate forms, right? So remember, this only works for indeterminate forms. So just make sure you guys don't get too happy about it and start applying it across everything, right? So example 1, find each of the following limits. The limit as x approaches 2 of 3x squared minus 7x plus 2 over x minus 2. So one of the things you guys notice here is, again, if I do plug it in, so we get the limit as x approaches 2 of 3 times 2 squared minus 7 times 2 plus 2. So you want to make sure that first you plug it in into each, and then try to figure out, and then establish whether or not it is the indeterminate form. So make sure that you do it separately, all right? It's very important. Don't just plug it in and then do 0 over 0. Just make sure you don't do that, all right? Just make sure that you do figure this out. So 3 times 4, that's going to be 12 minus 14 plus 2 gives us 0, all right? And then we're also going to do the limit as x approaches 2 of x minus 2. And that one's easy, right? It's just 2 minus 2 is 0. All right, so we can say, therefore, we can apply L'Hopital's rule. And then we're going to say the limit, right? Apply L'Hopital's rule. All right, so we can say the limit as x approaches 2 of the prime on top, that's going to be 6x minus 7 divided by the prime at the bottom of x minus 2 is just positive 1. So therefore, plug in 2, we get 6 times 2 is 12 minus 7 gives us positive 5. So that would be the limit for this as well, right? And then again, we do b here. So we're going to do the limit as x approaches negative 3. So we're going to say, first, if we plug it into the top, we're going to have the limit as x approaches negative 3. So it's going to be x plus 3, and that's going to be obviously equal to 0, right? And then the bottom, the limit as x approaches negative 3 of the square root of x squared, which would be negative 3 quantity squared, minus 5 minus 2. And that's going to, all the 2's on the outside, sorry about that. Okay. So it's just over these 2. Okay. And then from there, we're going to end up with, I was supposed to plug it into the first. Okay. So the limit as x approaches negative 3 of the square root of x squared minus 5 and then minus 2. So you plug it in and you end up with pretty much negative 3 quantity squared minus 5, square root of that, minus 2. That's equal to 9 minus 5, which would be just the square root of 4 minus 2. 2 minus 2 is equal to 0. So again, here we can say we can apply L'Hopital's rule, right? So therefore, L'Hopital's rule apply. You guys can always write this as many times as you want, and then you can just make sure you're stating it, right? Make sure you're stating that you're applying L'Hopital's rule. So here, if we do simplify, we're going to do the limit as x approaches negative 3 of 1 over, now, in this case, you're going to have to use chain rule, right? If you do use the chain rule, you're going to have 1/2 times x squared minus 5 raised to the negative 1/2 times the root of the inside, which is just 2x. This goes away with that nicely. And then you end up with the limit as x approaches negative 3 of the square root of x squared minus 5 over x. All right. And then from there, we plug it in. We plug in negative 3. We're going to end up with the square root of 9 minus 5 on top over negative 3. And that's equal to negative 2 over 3. Right? And then moving on to C. So same thing. We're going to be looking at the limit as x approaches negative 2 of x cubed plus x squared minus 8x minus 12. And then over x cubed plus 8x squared plus 20x plus 16. So again, let's first establish it. So we're going to say the limit as x approaches negative 2. On the top, we're going to have negative 2 to the third power plus negative 2 to the second power minus 8 times negative 2 minus 12. We simplify that, and of course, we end up with 0, right? And then do the same thing. So the limit as x approaches negative 2 of the denominator, which is x cubed plus 8x squared plus 20x plus 16, right? Yeah, I should have used x's up here on top as well, my bad. So that's x cubed plus 8x squared plus 20x plus 16. And again, if you do the substitution, you end up with 0. So again, we can say, therefore, again, L'Hopital applies, right? So L'Hopital applies. All right, and then from there, take the derivative. So we're going to say the limit as x approaches negative 2. On the top, we're going to have 3x squared plus 2x minus 8, and then divided by 3x squared plus 16x plus 20. And then from there, if you notice again, we do end up with 0 over 0. So here, since we do end up with 0 over 0, we can apply L'Hopital's rule again. So that's one of the nice thing about it, right? Like if we end up with another indeterminate form, we can apply it one more time. So let's do that. So we're going to apply one more time to figure out the limit as x approaches -2. Take the derivative on top, you're going to end up with 6x plus 2. Derivative at the bottom, you're going to end up with 6x plus 16. All right. And then from here, we plug in -2, and we end up with just -5/2. All right. So again, this is one of the nice things about it. You can always apply L'Hopital rule again, right? And then the last example right there, we're looking at the limit as x approaches 1 of 5x to the fourth minus 4x squared minus 1 over 10 minus x minus 9x squared. So again, let's make sure we apply, right? Let's do the limit as x approaches 1 of 5x squared, 5x to the fourth, sorry, minus 4x squared minus 1. Again, you plug in 1, you end up with 5 minus 4 minus 1, which is the just positive 0, just 0, right? Not positive, just 0. So the limit as x approaches 1 of the denominator, which is 10 minus x minus 9x squared, which again would be just 0 one more time. So we take the derivative, right? Therefore, again, state it. Make sure you guys are saying it. L'Hopital applies, right? And then we're going to say that pretty much the derivative of the top. So this is going to be the limit as x approaches 1 of 20x to the third power minus 8x divided by, it's going to be -1 minus 18x. And then we throw in the 1 again, we're going to end up with 20 minus 8, which is just positive 12 over -19. So that's our answer. So it's really important that you never write, again, the limit as x approaches c of f of x over g of x equals 0 over 0, or the limit as x approaches c of f of x over g of x equals infinity over infinity. So neither 0 over 0 and infinity over infinity are numeric values and thus cannot be equated to any other expression. So make sure you guys are just using the arrows, right? If you noticed here, I used the arrows because, again, I had to apply L'Hopital rule one more time.